In this question, we have this compound, aqueous, going to 2H plus and C2O4, 2 minus. So essentially what we want to do here is we want to write the equilibrium constant expression for this reaction. And I want to derive this for you in this particular case, and then I'll show you at the end the easier way to do this. So first of all, we have to realize that this is a reversible reaction. And the rate of the forward reaction equals K1 concentration of H2 C2O4. So it equals the concentration of this times the rate constant. The rate of the reverse reaction, rate, equals K minus 1 for the reverse reaction, concentration of H plus squared, because there's two of them, and these are elementary reactions, so you're allowed to do this, concentration of C2H4, 2 minus, like that. So the forward reaction has this rate law, and the second reaction has this rate law. And again, this is an elementary reaction that is reversible. Now, what we need to remember is that at equilibrium, the rate of the forward reaction and the rate of the reverse reaction are equal. Said another way, K1 times the concentration of H2C2O4 equals K minus 1 times the concentration of H plus squared, concentration of C2H4, 2 minus. So these two things are now equal to each other. Now we want to rearrange, because for the equilibrium constant expression, we want the K's all together. So I'm going to divide this by K minus 1, and I'm going to divide this side by concentration of H2CO2O4. What I'm going to get is K1 over K minus 1. So I divided both sides by K minus 1 equals concentration of H plus squared, concentration of C2H4, 2 minus, divided by concentration of H2C2O4. Now, K minus 1, or excuse me, K1 over K minus 1 is a constant over a constant, which is just a new constant, which is sometimes called K and sometimes called KEQ. And this is how you would derive this expression. Now, you probably don't need to continuously derive this expression. I just wanted to show you where it came from. Since you did all the work in the previous chapter to learn about this rate law stuff, this is where the equilibrium constant expression comes from. So what you could think about this is K, or KEQ, depending on the source, equals the concentration of, these are the products on the top, the concentration of the products, which there may or may not be more than one, over the concentration of the reactants, or reactant in this case. So the equilibrium constant expression is the concentration of each product raised to the appropriate power, if there's more than one of them, over the concentration of the reactants. In this case, there's only one, so it's just raised to the 1. And you can use this general form. You don't need to derive this every time in order to get the equilibrium constant expression. Finally, if you have things in here that are solids or liquids, we do not put them in the equilibrium constant expression. And one reason that might be is because you can think of them as essentially constant. So if you have water here as a product or a reactant, and these are aqueous in solution, there's a lot of water present, and essentially the amount of water does not change. So if it's a liquid or a solid, we don't put it in the equilibrium constant expression. If it's usually aqueous or a gas, we do put it in the equilibrium constant expression. So that's just an important thing to remember.